Hello, this is a walkthrough video for Lab 303 where we learn how to construct a star schema from information given about a business. But you have a problem statement given and you are supposed to create a star schema. Before we get into this, let's quickly cover some of the concepts related to the star schema or the dimensional modeling. So, a dimensional model is a retrieval-based system that supports high-volume query access. And no matter what architecture you want to make, the design of data representation in a data warehouse is focused on the concept of dimensional modeling. There are two common types of dimensional modeling techniques. One is a star schema, the other one is called snowflake schema. Star schema is the simplest style of dimensional modeling and very commonly used. It contains a fact table surrounded by and connected to several dimension tables. That's the one we have to make for this assignment. So this is how a star schema and snowflake schema look like. A star schema is a simple database design in which dimensional data are separated from fact or event data. Another name for star schema is dimensional model. The star schema is composed of fact table in the center and dimension tables. Note that the fact table is in essence an associative entity that joins various dimensions together. The dimension tables are usually the source of the attributes used to qualify, categorize, or summarize facts in the queries, reports that you are making. So the fact table can contain factual or quantitative data or facts, and they can also contain measures. So let's look into these terms. We will look at facts and measures which are contained in the fact table, and then the dimension tables have dimensions. So let's look at these terms. Facts, according to the Kimball group, are the measurements that result from a business process event and are almost always numeric. A single fact table row has one-to-one relationship to a measurement event as described by the fact table's grain. What is grain? Grain is the granularity of the fact table. It means what level of detail do you want. A measure is a numerical property of a fact, and it describes a quantitative fact aspect that is relevant to the analysis. Measure is numeric and additive. Facts and measures are both present in a fact table. Now the dimensions provide who, what, where, when, why, and how context surrounding the business process event. The dimension table contains the descriptive attributes used by BI applications. So usually if you want to identify what the dimensions are, if you are reading the problem statement, you will find the nouns which are describing objects that participate in the business or business process. Those nouns are the dimensions. So now I have closed the presentation. You can find those slides uploaded in your course module, as well as you will see a lecture uploaded about it. So that's what we needed for this exercise. Let's go back to the exercise. And what you need to do is you have been given a problem statement which describes certain business processes and what's going on there. We need to read this and identify what are facts, what are measures, what are the dimensions, and then go ahead and answer these questions. Later on, once we have answered these questions, we'll have a better understanding of what is dimension, measure, facts. Then we can go ahead and create a database diagram for this problem. So let's look at the problem statement. So first thing we said was dimensions are nouns. So as we read through this, we are trying to identify possible nouns from here. A vehicle repair shop has fleet cars that come in frequently for regular service. Okay, as I'm looking through this, so this is a vehicle repair shop. Since we are only going to have one of it, this may be just the context in which this problem statement is framed. So this may not be one of the dimensions. So let's go ahead and see. We have what? We have the regular service. So maybe service is a possible noun. For now, I'm just highlighting it. Each service has service code and description. From that, I think that service is a dimension and the attributes of that service are service code and description. For now, let's go ahead and make these as underlined. So these two look like they are the attributes of service. Now each vehicle serviced is of certain type. So it looks like vehicle is a noun that we might be interested in as a dimension. This is a possible candidate for dimension, vehicle. And then the attributes are going to be type and make for that vehicle. So we have some descriptive variables describing or defining something about the vehicle. Now, when a vehicle arrives at the shop, a mechanic will inspect the vehicle and provide a diagnosis of what is needed. So, other possible dimensions are mechanic and then diagnosis. So for now, let's highlight these and then we'll be looking for measures of these, of what is needed. Each diagnosis has a code and a description. So, well, code and description looks like these are going to be describing or are the attributes of diagnosis. The chief mechanic at the repair shop wants to be able to do certain things. So it looks like the mechanic is possibly one of the dimensions, and what the mechanic is doing, we are going to record that as well. So far we have 4 potential dimensions: vehicle, service, diagnosis, and mechanic. One thing that we have not done so far is if the questions are, or if the problem description talks about time as like per week, per month, per year, then time needs to be another one of our possible dimensions.